12th class, 3rd chapter, 14th session. Kirchhoff's voltage law. Students feel it a bit confusing when it is applied. So I suggest you to concentrate more intensely, that there is no doubt left about applying the law. It's otherwise known as a loop rule. Why it is called a loop rule? Say I draw a circuit. Here there is a cell of EMF E1 and internal resistance R1. This is an external resistance R1. Another cell of EMF E2, external resistance R2 and internal resistance R2. Now let's see what happens here. Let's mark the current. See here, current will be from positive to negative. So from this cell, I1 current will be coming out and that will flow like this. From this, I2 current will be coming out and that will flow like this. At this junction, they will be combined and finally it will be moving through R3 resistor as I3, and this I3 will come this way and it will be splitted as I2 to move this way and I1 to move other side, so that the circuit is complete. Okay, this is a complete circuit. Now let me apply, let me name the different points. Let me call it as A, B, C, D, E, F. Okay. Now, what is Kirchhoff's voltage law? Kirchhoff's voltage law, first of all, I will give you the statement. Okay. It's applicable only for closed loops. What? Applicable only for closed loops. Kirchhoff's voltage law is applicable only for closed loops. What are the closed loops? This one is a closed loop, A, B, C, D, A. It's a closed loop, right? A, B, C, D, A. It's a closed loop. Now if I name another closed loop, it is A, D, E, F, A. It's another one closed loop. A, D, E, F, A. It's another closed loop. Is it complete? No. One another closed loop can be B, C, E, F, B. That is one another closed loop, right? So it can be B, C, E, F, B. That is one another closed loop. We should apply Kirchhoff's voltage law only for closed loops. We should apply Kirchhoff's law only for closed loops. So we can apply Kirchhoff's law for these loops. So that's why we call it as a loop rule. And what is a Kirchhoff's voltage law? What actually it says? It says that for a closed loop, the sum of the product of current and resistance is equal to algebraic sum of EMF inside that loop. What? You take a closed loop, and in a closed loop there will be EMF and IR. See, there is current flowing through resistor, so there will be IR. And at a closed loop there are EMF. So what you have to do is take a closed loop, write all EMF one side, and write all IR the other side, add it all, and that will be equal. Okay, let's apply it. Again, first I will give you a wrong equation, then I will correct it so that there is no confusion. So let's write it, right? So what we need, we have to select one closed loop and identify what are the different resistors and current flowing through that resistor, and we have to multiply IR. I have to add those all IR. Next, at the right side, you have to write EMF. You have to write all EMF and add all those EMF. Okay, let's apply. A, B, C, D, A. So in this closed loop, what are the different IRs? Here there is I1 R1 and there is I3 R3 and there is same current I1, right? I1 R1. These are IRs. Can you understand? IR, the product of current and resistance. The product of current and resistance, here it is I1 R1. Here it is I3 R3, because we are considering only this closed loop. and current like flows like I1 R1. So all these, you have to add all this. Equal to, add all EMF. Yeah, there is only one EMF, which is E1. Okay. Okay. Now take the other closed loop. Other closed loop will be, what was it? A, D, E, F, A, like this. So it is I3 R3. Next is I2 R2. Next is I2 R2. So we have to add all this. Sum equal to, there is only one EMF, E2. And for the whole bigger loop, BCEFB, yeah, BCEFB, there is I1 R1, I1 R1 through this, or for all resistor current flows, so there will be IR. For all resistor, IR will be there. I1 R1, yeah, I2 R2, I2 R2 equal to, finished, right? Equal to, see, I1 R1, I1 R1, I2 R2, I2 R2, yeah, finished. And there are two EMFs, E1 and E2. So it will be E1 plus E2. Okay. But these equations are wrong. It's not properly executed. Now, how can you execute it properly? See, this is wrong. How can you make it correct? Again, we need a sign convention. You have to write this sign convention, right? One, sign convention for applying Kirchhoff's voltage law. Sign convention for applying Kirchhoff's voltage law. First one. Name a loop. First step one, name a loop. Imagine, second step, imagine that you are walking through the loop in that direction. What direction? In the direction you named. Just like you imagine you are walking like B, C, D, A, B. So name a loop. Imagine you are walking through that loop in that direction. Third step, during the travels, when you travel through the loop, you will find a resistor and an EMF. Okay? You will find current through, during the traverse, you find current flowing through resistor and battery or EMF. That is the next step. During the traverse, you will find current through resistor and EMF. Right? Next, it's very important. If the current through the resistor is in the same direction of your traverse, that current is positive. Remember, you are walking through the loop and you are meeting a current through the resistor. If you are walking along the direction of the current, then that current is positive, that IR is positive. And if you are walking opposite to the direction of the current, that current is negative, that IR is negative. Okay, just understand it. When you are applying, you will understand it very clearly. During the traverse, if you meet a current along the direction of your traverse, that current is positive, otherwise negative. Okay, now, while you are traveling, you will meet battery or you will meet cell. You will meet cell. If you are meeting negative of the cell first, listen, if you are meeting negative of the cell first, that EMF is positive. If you are meeting negative of the cell first, that EMF is negative. Sorry, that EMF is positive. Or if you are meeting positive of the cell, that EMF is negative. Ulta. So if you are meeting the negative of the cell first you are meeting negative of the cell, that EMF is positive. So I am taking enough time. because it's something which the students usually say difficult to understand. So we have to vanish all those doubts possible. Now let's apply it. So what was it? If direction current same, current positive, IR positive. If you are meeting negative of the battery first, that EMF is positive. That two sentences is enough. What? Direction current same, IR positive. If you are meeting negative of the cell first, then that EMF is positive. Okay. So how can you write it? For this one, you are moving like this, right? So I1 R1 is negative. You are moving like this, current is along this way. And this I1 R1 also negative. Okay. And you are moving like this because you named the loop like this. You are moving like this. Current is in the opposite direction, so that I3 R3 was also negative. And while traveling, you meet the positive of the EMF first, right? You are moving like this. So you are meeting positive of the battery first. So that EMF is negative. That's it. Now for the second loop, ADEFA, you imagine to move like this. When you are moving like this, current I3 and your direction of travel is same. So that is positive. Okay, that is positive. I2, yeah, I2 you are moving, current in the same direction you are moving. So that also is positive, correct? No change. Here also I2 R2, yeah, there is no change. And you're meeting the negative of the battery first, that also is positive. Yeah, it is correct. So that was coincidence, that was correct. Now, see, previously, this was the equation for the big branch or big loop. You are moving like this, right? So this will make you clear about applying the loop. So you are moving like this. So here I1 R1, you are moving like this, current is in the opposite direction, so that is negative. Okay, you are moving that direction, current is in this direction, so that also is negative. Here you are moving in the same direction of R2, so that current is positive. No change. Here also you are moving in the same direction, that current is positive. Correct. Here you are meeting the negative of the battery first, that EMF is negative. And here you are using, here you are meeting positive, here you are meeting positive of the cell, so that is negative. Here you are meeting negative of the cell first. Yeah, first you are meeting positive of the cell, so that EMF is negative. Here you are meeting negative of the cell first, so that EMF is positive. So this is the explanation. So what was the result? Algebraic sum of the product of current and resistance in a loop is equal to the algebraic sum of the EMF in the loop. So you have to study this way. And it's a law of conservation of energy. Kirchhoff's voltage law is a law of conservation of energy. And this law will be in use for solving so many problems. See, you have to understand one thing. I'm giving you only the basic class. It's only a basic class. And we have to apply these basics. So I wish you confirm these basics. If you confirm this basic, I'm very sure you will be able to do any problems, any related theory with +2 physics. So you have to understand the basic concept so clearly. Okay, that's it. Kirchhoff's voltage law, it's a law of conservation of energy.